What was there before the Big Bang? 15 billion years ago, something illogical happened. Every atom in your body, every star in the sky, every galaxy we can see, all of them burst forth from a point smaller than the period at the end of this sentence. But here's what's really interesting. The Big Bang might not have even been the beginning. The singularity problem. When scientists try to understand the first moment of the Big Bang, it's like trying to divide by zero. The result always comes up error. This is called the singularity problem. According to our best theories, if you rewind the universe like a movie, everything shrinks and eventually reaches a point of infinite density and infinite temperature. It's like trying to squeeze all the people on Earth into a pinhead-sized area. The laws of physics become meaningless under these extreme conditions. What's even astonishing is that this isn't just about the beginning of matter and energy, it's about the beginning of space itself. Before the singularity, there wasn't even emptiness. There was no place for anything to exist. The temperature would be 10 million trillion degrees, hot enough to make the sun's core look like an ice cube. At this temperature, not just atoms, but even the fundamental particles that make up atoms would transform into pure energy.
Quantum foam. Welcome to the smallest scale of reality. At distances smaller than 10 to the negative 35 meters, space isn't smooth like we think. It's bubbling and churning like boiling water. Scientists call this quantum foam. Think of looking closely at the surface of a calm lake. From far away, it looks perfect. Get closer and you see waves. Get even closer and you see a chaotic dance at the molecular level. The same thing happens when you zoom into the fabric of space. At the quantum foam level, particle pairs spontaneously appear and annihilate each other in less than 10 to the negative 43 seconds. Even light can only travel 10 to the negative 35 meters in this time. Here's the amazing part. This quantum foam existed even before the Big Bang. Even though everything we know about our universe began 13.8 billion years ago, the quantum foam was always there.
Cosmic inflation. In the first tiny fraction of a second after the Big Bang, something extraordinary happened. The universe exploded faster than the speed of light. In just 10 to the minus 36 seconds, a region smaller than a proton reached the size of a grapefruit. Recent research shows that our inflation might be just one episode in a much longer cosmic drama. Before our inflation began, space may have gone through cycles of expansion and contraction. The bouncing universe. What if the Big Bang wasn't a beginning, but a bounce? Scientists are discovering that our universe might be in an infinite cycle of expansion and contraction. Think of a cosmic heartbeat. Our universe expands for billions of years, reaches maximum size, then begins contracting back. But instead of collapsing into a singularity, it bounces back and triggers a new Big Bang. Each cycle lasts approximately 1 trillion years. We're currently about 15 billion years into the expansion phase. We have another 986 billion years before the universe starts contracting again. Colliding brains. What if our universe was born from the collision of two three-dimensional brains hurtling toward each other in higher dimensional space? This is called the ekpyrotic scenario. Imagine two massive soap bubbles floating toward each other in a tub. When they touch, they create waves and vibrations. In this case, the bubbles are entire universes, and the waves become matter and energy filling all of space. The collision happened approximately 13.8 billion years ago, but the brains themselves could be infinitely old, drifting through higher dimensional space for eternity. Loop quantum gravity. What if space itself has a smallest size, like pixels on a computer screen?
Loop quantum gravity proposes that space is made of fundamental building blocks, like atoms. In this theory, the density of matter can never be infinite because space itself has a minimum size. As the universe contracts, space compresses until its loops are pressed as tightly as possible. At that point, space pushes back. At maximum compression, the universe would have a density of approximately 10 to the 96th kilograms per cubic meter. A teaspoon would be heavier than all the matter in today's observable universe. Extra dimensions. Our universe might have a hidden secret beyond the 3 spatial dimensions we experience daily. String theory proposes that the fundamental building blocks of reality aren't particles, but tiny vibrating strings existing in 9 dimensions plus time. Before the Big Bang, these extra dimensions might have been large and accessible. The Big Bang could have been the event that caused 6 of these dimensions to curl up and hide. Eternal inflation. While our Big Bang happened 13.8 billion years ago and inflation in our region ended almost instantly, inflation doesn't actually stop everywhere. In the larger cosmic structure, space continues inflating forever, constantly creating new universe bubbles like ours. Think of a pot of boiling water. Bubbles keep forming, but each bubble is a complete universe with its own Big Bang. The eternal inflation scenario shows that every universe that could exist actually does exist. Universes where gravity is twice as strong, universes where electrons have different masses, they all exist.
Universe inside a black hole. What if our entire universe exists inside a black hole? When a massive star collapses and forms a black hole, the mathematics shows something extraordinary happens. The collapse can create an entirely new region of space-time that, viewed from inside, looks like a rapidly expanding universe. If our universe is inside a black hole, that black hole exists in a larger parent universe, and that parent universe could be inside an even larger black hole, an infinite hierarchy of nested realities. The holographic universe. Reality might be an illusion. Everything you think exists in 3-dimensional space might actually be information encoded on a 2-dimensional surface. The holographic principle emerged from studying black holes. Matter falling into a black hole appears to disappear forever, but the laws of physics say information can't be destroyed. So where does the information about that falling matter really go? The answer changes everything. The information doesn't fall inside the black hole. Instead, it's encoded on the black hole's event horizon. Recent mathematical breakthroughs show that our entire observable universe might work this way.
Quantum tunneling. Nothing can become something. In the quantum world, universes can definitely tunnel from absolute nothingness into existence. And our universe might have started exactly this way. Before the Big Bang, there was no space, time, matter, or energy. Literally nothing existed. But in quantum mechanics, even nothing is something. The quantum vacuum is full of virtual particles, energy fluctuations. In this quantum nothingness, there's a small but non-zero probability for a universe to spontaneously tunnel into existence. A universe created through quantum tunneling would naturally have exactly 0 total energy. The multiverse. Our universe isn't alone. Our reality is probably just one of an infinite number of realities existing simultaneously. And whatever happened before our Big Bang might be happening right now in countless other cosmic realms. The multiverse isn't a single theory, it's the conclusion of many different areas of modern physics. Whether you follow the mathematics of eternal inflation, string theory, or quantum mechanics, you arrive at the same place. Reality is much bigger and stranger than what happens in our observable universe. Gravitational waves. Space itself rings like a bell, and the echoes might be messages from before the beginning of time. Gravitational waves are ripples in the fabric of space-time and carry information about the most violent events in cosmic history. The most important gravitational waves might be the primordial ones we haven't yet detected. If any of the pre-Big Bang scenarios are true, they must have produced gravitational wave signatures that are still traveling through space today. Different pre-Big Bang theories predict different gravitational wave signatures. A cyclic universe creates specific frequency patterns. Colliding branes produce different patterns. Cosmic microwave background radiation. The oldest light in the universe is trying to tell a story about what happened before everything began. The cosmic microwave background radiation is the echo of the Big Bang. When scientists map this radiation with incredible precision, they find tiny temperature variations showing how matter was distributed in the early universe. But hidden within these temperature patterns might be signatures of events that occurred before the Big Bang itself.
Dark energy. Something is tearing the universe apart, and it might be connected to what happened before the Big Bang. Dark energy makes up approximately 68% of everything that exists, but we have no idea what it is. The only thing we know is that it's causing the universe's expansion to accelerate. The amount of dark energy in our universe is almost exactly what you'd expect if our Big Bang emerged from a larger cosmic structure. The nature of time. What does before mean when time itself didn't yet exist? This isn't just a philosophical puzzle, it's one of the deepest challenges in understanding what might have happened before the Big Bang. In our daily experience, time is like a river flowing from past to future. Events have causes that come before them. But at the moment of the Big Bang, according to our best theories, time itself began. Quantum mechanics offers a strange solution to this paradox. In the quantum realm, causality becomes blurred. Events can happen without clear causes. Effects can come before their causes. The information paradox. Information is more fundamental than matter and energy. You can convert matter to energy, energy to matter, but information cannot be created or destroyed. Our universe contains an enormous amount of information. Every particle has properties like mass, charge, spin. Every atom has a specific structure. Where did all this information come from? The holographic principle offers a striking solution to this paradox. If our three-dimensional universe is actually a projection of information stored on a two-dimensional boundary, the Big Bang might not be the creation of new information, but the moment when pre-existing information began reflecting our reality. Quantum entanglement. When two particles become entangled, measuring one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance. But recent theoretical breakthroughs show that entanglement might extend far beyond our cosmic boundaries. If multiple universes exist, particles in our reality could be entangled with particles in parallel realities. Consciousness and reality. What if consciousness doesn't just observe the universe, but helps determine which version of reality becomes real? In quantum mechanics, particles exist in multiple states simultaneously until the moment they're observed. The famous double-slit experiment shows that a photon can pass through two different paths at once. But the moment you try to measure which path it took, the superposition collapses. If consciousness is necessary to collapse quantum states, the emergence of consciousness in our universe might have retroactively determined which cosmic history became real. The mathematical universe. What if our universe isn't made of matter and energy,
but of pure mathematics expressing itself as physical reality. Every particle, every force, every law of physics would be mathematical entities playing by logical rules. The mathematical universe hypothesis explains why mathematics is so incredibly effective at describing physical reality. If reality is mathematics, the effectiveness of mathematics simply becomes logical.
Vacuum decay. What we call empty space isn't actually empty. It's filled with quantum fields permeating every cubic centimeter of the universe. Our universe might exist in a local energy minimum instead of the true ground state. Like a ball sitting in a shallow dip on a high slope. The ball looks stable and safe, but if it gets a small push, it could roll out of the dip and fall to a much lower position. Our universe might be that ball. If vacuum decay occurs, it would happen through quantum tunneling. Somewhere in the universe, a small bubble of true vacuum spontaneously appears, expands at the speed of light, and transforms everything it touches into a lower energy state. Cosmological natural selection. Universes might evolve, reproduce, and compete for survival just like living organisms. This isn't a metaphor, but a serious scientific theory applying Darwin's principles of evolution to the cosmos itself. Think of black holes as cosmic reproductive organs. When a black hole forms, some theories propose it creates a new universe on the other side of the event horizon. Universes that produce many black holes have many offspring. Universes that produce few black holes have few offspring. Over countless cosmic generations, the multiverse fills with universes optimized for black hole production.
The simulation hypothesis. What if all our reality is a simulation running on a cosmic computer, and what we call the Big Bang was simply the moment someone pressed the start button? As our own computing power grows exponentially, we're beginning to create cosmic evolution simulations. Advanced civilizations with vastly more computational resources could potentially simulate entire universes filled with conscious beings who believe their reality is fundamental, not artificial. Recent calculations are astonishing. A civilization just a few hundred years more advanced than us could have enough computational power to simulate the entire history of our observable universe in full detail. Testable predictions. All these crazy theories aren't just philosophical speculation. They make specific predictions we can test with actual experiments and observations happening right now. Gravitational wave detectors are already online and becoming more sensitive every year. Next-generation space-based gravitational wave telescopes will be sensitive enough to detect the primordial gravitational wave background that could reveal which cosmic event came before our Big Bang. Advanced telescopes like the James Webb Space Telescope are looking deeper into space and further back in time than ever before. They're seeing galaxies formed when the universe was very young, potentially revealing information about conditions before normal cosmic evolution.
Humanity's place. If our universe is part of an infinite cosmic cycle, we're not at the beginning of everything, but somewhere in the middle of an endless story that's been continuing since eternity. If our universe emerged from the collision of higher dimensional brains, we're living in the wreckage of a cosmic accident occurring at scales we can't imagine. If we're living inside a black hole, every black hole we observe might contain its own universe, with galaxies, stars, planets, and potentially life. The most radical possibility is that consciousness plays a fundamental role in determining which version of reality becomes real. If the multiverse contains all possible histories simultaneously, the emergence of awareness might be what selects our particular cosmic timeline from infinite alternatives. As we develop more advanced technologies, we might gain the ability to detect and even interact with these larger cosmic structures. future civilizations might learn to communicate across universe boundaries, travel in extra dimensions, or even create their own new universes. The Big Bang wasn't a beginning, it was a transition. And we're not the final product of cosmic evolution. We're participants in this vast cosmic drama. We're part of a story without end. There's only infinite transformation and discovery. What happens next doesn't just depend on the laws of physics, it will also depend on what we choose to do in the brief moment of consciousness we've been given in this vast cosmic drama. When you lay your head on the pillow, think about this. Perhaps right now, in a very distant parallel universe, another you is asking the same questions. And maybe one day we'll discover the connections between all these universes. You're not just a being made of atoms. You're part of the universe's journey to know itself. You're an ongoing chapter of a 15 billion-year cosmic story. Every atom, every breath, every thought, they're all part of a tremendous journey coming from infinity and going toward infinity. Thank you for listening to me. Good night and sweet dreams.